A 30 ohm resistance is connected in parallel with a resistor R whose ohmic value is unknown. If the total current taken by both resistors is 5.7 amps, when the current EMF is 114 volts, calculate the resistance of the unknown. Let's go ahead and draw the circuit first. We have two resistors connected in parallel. Let's call the first resistor R1, which has a resistance of 30 ohms, and R2, which has an unknown value. The total current IT flowing through the circuit is 5.7 amps, and the voltage EMF is given by 114 volts. Since the two resistors are connected in parallel, the current flowing out of the source will split in this node, and will combine again in this junction, going back. Therefore, the current flowing through these two resistors are of different values. Note that you cannot just divide 5.7 into 2, okay? We can get the current by using Ohm's law. So now, how can we find R2? We must first find the individual currents flowing through these resistors, and by that, we can finally get the resistance of R2. Okay, for I1, we can just simply substitute the given values. So that's 114 volts divided by 30 ohms, and that's 3.8 amps. Alright, so since the total current is 5.7 amps, and when it split through this node here, the 3.8 amps went down passing through R1. So how much current do you think went through this wire passing R2? Yes, you got it right. We have to subtract I1 from the total current. So mathematically, I2 is equal to IT, or total current, minus I1. Therefore, we'll get 1.9 amps. Now we can finally solve for R2. From Ohm's law, we know that resistance is equal to voltage over the current flowing through that resistor. Substitute the values, 114 volts over 1.9 amps, and we'll get 60 ohms.